If we were conducting the course physically in the class, then usually after about 1 hour or say halfway between the lecture, I would allow a break. I am a very firm believer that the human mind cannot continuously work for a long time at high efficiency. So a small break really helps. So if you were in the class, we will say that please for 5 minutes you can go outside, walk a little, take some water, physically refresh yourself and then come back. And once you come back, then it has been my tradition, it is not necessary that that was the physical break, you go outside of the class, walk around, come back. And now for a few minutes we will have a mental break. For a few minutes we will talk of something which is totally unrelated to the course. So mentally you are also refreshed. And then we will start the regular lecture part and so on, right? So that is a tradition with me that we will still do. Now, what I cover in these mental breaks can change from time to time. My problem is that those students who have been with me in a previous course sometimes may find that the mental break is repeated. So sorry to those guys if that happens, and otherwise that is it. One of your favorite parts, I hope, the break time. This time let us talk about some science and math. Okay, some science and math. We are assuming that the world is finished, the day of judgment, Qiyamah and all that has gone, and now it is the Akhirah time. The scientists are in Jannah, in Firdaus. You see, they have done so much for the world. Each scientist, because of science and so on, has helped hundreds and thousands and millions and billions of people. So they are in Jannah. Now they are collected there. They are talking to each other. They say, you see, when we were in our life, we were always working and in labs and equations and modeling and this and that. Now let us relax. So let us do things which we never did. Let us play some games which children usually play. Is it okay? This is a good idea. So there is a game called hide and seek. It is there in every language in the world, that you see one person has to find the people and everybody else goes and hides it. So, right, so this is called hide and seek. So they are in a park and so on. So the first time, Einstein, he has to find the people and all others have to hide. So everybody goes, hides behind some tree, behind some bush, in a ditch, in some place. Newton walks 10-15 steps and takes a piece of chalk or a stone or something, makes a small square there, and he stands there and he does not go and hide. Now Einstein has his eyes closed. He is counting 1, 2, 3, 4, 5, and everybody knows that once he will say 50, then he will open his eyes and then he will try to find out. So once he counts 50, he opens his eyes and Newton is right in front. He says, Newton is out, Newton is out, Newton is out. So all scientists come out now from the hiding. Newton says, no, Newton is not out. Newton is not out. They are saying, what do you mean? You were right there in front. He says, no, Pascal is out. Pascal starts screaming, I was hiding behind the tree. What do you mean Pascal is out? He says, see here, this square I am standing is 1 square meter. And I am Newton. I am standing here. Newton per square meter. Pascal is out. So before the break, we were talking of how do you define manufacturing, and we said that yes, converting raw material into a finished product is manufacturing, and in doing that you can use
machines and tools and manpower and energy, and that your manufacturing can be directly to a finished product, or the products that you manufactured can be used to manufacture more complex products, right? So that was what we did. I am just showing you as an example, 787 Dreamliner came out a few years ago. This was the biggest aircraft by Boeing, right? And this is the hangar inside where it is being assembled and manufactured. So I am showing you this as a manufacturing activity, But I am showing you a hugely complex product, a very, very big size, humongous, and a very, very complex product. There will be thousands and thousands and thousands of parts inside there. If the whole aircraft is an assembly, then each wing, each tail, engine, cockpit, main area will be sub-assemblies. In each of these sub-assemblies, there may be smaller sub-assemblies. In each of these smaller sub-assemblies, there may be hundreds of different parts, right? So it's a very complex product, but at the very individual small component level, going down to a nut or a bolt or a small seat, you have to do manufacturing. And then you combine a lot of these parts into something complex like a wing, and that is still not the whole thing. And there is mechanical engineering, electrical engineering, civil engineering, right? Lots of things inside there, electronics, right? So any large complex product, when you do the manufacturing, then it's a very complex process, and all types of engineering knowledge can be used inside that, right? So this is just an example to show you the extent of manufacturing. Evolution, right? Evolution, right? I mean, how things evolve over the years. Evolution, right? How things evolve over the years. So manufacturing began about 5000 to 4000 BC. You see, right now you are in 2021. So more than 2000 here and 5000 there. So overall about 7000 years earlier. So manufacturing began with the production of various articles of wood, ceramic, stone and metal. So you should not feel that, you see, you are something in a course which is only very modern. From the earliest time that mankind has been there, manufacturing has been there. It is derived from the Latin word manu factus, meaning made by hand, So that is how the word is started. But then this was converted into the word manufacture, and this word was first used in the English language in 1567. And then the word manufacturing came in 1683. So just imagine, right? It took more than 100 years to go from manufacture to manufacturing. And then the word production is also used interchangeably for manufacturing. You can say, I produce it, I manufacture it. I am doing production of this part, I am doing manufacturing of this part. This is still the same. Why am I doing this? You see, this linguistic part of it, this language part of it, you can leave it and still go. But my very strong feeling is that, you see, language is very critically important. I mean, if your teacher is brilliant in his research and very expert in his area, but his communication is weak, he cannot explain things to you very nicely, very clearly, very concisely, then as a teacher, he is not good for you. As a researcher, he may be brilliant, but as a teacher, right? So communication is very important. Engineering, every idea, every product, every design, you have to communicate it to your team members, to your management. So language is critically important. And every word has some origin. So if we understand the origins of the word, and if we understand the basic meaning of that word in the language, then we can relate it much more easily to what is the scientific meaning or what is the engineering meaning of that word. So from time to time, we will be doing that, right? Going into the language part of the name. Here, now I have an example, right? The question is, what is manufacturing? What is manufacturing? I am using, you see, Oman, a large part of Oman is agricultural lands, mashallah, right? You have your nakhls and date palms and this, and you produce a lot of vegetables, this, that. So lots of, so farming, you know, tractor is a major farm equipment. Tractor is a major farm equipment. You use it for lots of work inside the agricultural farms and so on. I am taking this as an example in response to the question, what is manufacturing, right? So range of materials and processes in a tractor. What are the different types of materials that are used in this product, and what are the different types of manufacturing processes that are used? So for example, this part inside, I'm showing you an enlarged one in the inset is of course the engine part and so on. So if you see steel pistons with friction welded skirt and crown and chrome molybdenum disulfide coated piston ring. So the materials are steels and chrome molybdenum disulfide coating on the piston ring. So they are high quality steels and high quality metal coating on that. And friction welding will be one method, isn't it? And all the things will be cast. Die cast aluminum valve cover. So aluminum is there, but die casting is the method. Centrifugal cast iron cylinder bores. So cylinder bores are there. Cast iron is the metal, right? And centrifugal casting is the manufacturing method. Aluminum, copper, nickel, journal bearings. So these are different types of journal bearings made of aluminum or copper or nickel, and journal bearings will be manufactured by certain methods, right? Fiberglass hood, copper tube, aluminum fills. So if you read it, what I would have done normally, that I show you the picture and I ask you that please look at this picture for half a minute and then don't look at it anymore. And I am going to ask you that give me the names of some of the materials that were there in the picture. So you will try to remember steel, aluminum, right, molybdenum. And I'll ask you that try to give me names of some manufacturing processes that you saw there. Or I could not show you the picture, I show you the picture and say that you yourself think that this is a tractor. Don't read anywhere, don't look at anything. Try from your mind to come up with what different types of materials are there, what different types of manufacturing processes are there, right? So just look at this now. In the future, you can look at it yourself and try to find. But right now that you see, any modern product has a lot of different materials, very complex materials, metals, ceramics, polymers and so on, and lots of different manufacturing processes. Casting, welding, forming, extrusion, this, that, assembly, right? So any product in the world, small or large, has a lot of manufacturing involved in it. And this example was again, right? The previous example was a big Boeing jet. This example is agricultural machinery. They are examples from mechanical engineering basically, but they have a lot of structural parts in it and a lot of electrical parts in it. So other engineerings combined into it. So with this, we finish your very first introduction lecture of the course on manufacturing. Hopefully you are excited. Hopefully you are motivated that this is a critically important course, not just because it was in the degree plan, but because every engineer definitely needs it. And hopefully we are having a good overall view of the whole field of manufacturing rather than only individual chapters. So we will see you next time, inshallah. For now, ma'as salama from my side.